Okay, this is the review for College Algebra Test number 2. In problems 1 through 4, you're asked to tell whether the equation defines y as a function of x. So you can either have the shapes memorized for these equations and know what kind of graph you'd be dealing with, even though you might not go as far as thinking about the precise details of the graph, but if you just simply know the shape, you can answer a question about whether or not it's a function. So if you do realize that this is all first degree in these variables x and y, the graph has to be a line. Now whether it goes this way or that way would not stop you from answering the question as to whether it's a function. So this would be a line. It would pass the vertical line test. So yes, this would be a function. Now let's say you don't know your shapes. If you don't know your shapes, what you should do is solve for y. That means you'd have to get this 5x over here. Get the y completely by itself. Oops, that's a positive 6. You'd be dividing that by 6 as well as that. And then you could put it in the calculator. Negative 5x over 6 plus 1. I divided that side by 6 as well as this side. So that division belongs to the first term as well as the second term. Okay, if you want to put that in your calculator, the y is equal to, only because let's say that you don't know your shapes, you could enter it in the calculator. Negative 5x divided by 6 plus 1. You could graph it. You would see that it is a line. I don't know if you could see that. The graph would be a line, and that line would pass the vertical line test. Now this does happen to be a line that climbs to the left, but regardless of whether you graph it this way or the other way, if you just know the shape, you know whether or not it's a function. So yes, this is a function. Okay, problem number 2. Problem number 2, same comment that I'm going to make. You would have to solve for y if you did not know what the shape is by bringing the 3x to the other side. Divide both sides by 7. Split up the terms. So it would be negative 3x over 7 plus 10/7. You could put that into your calculator. It would be a line that climbs this way, just like that one is actually a line that climbs to the left. And again, it would pass the vertical line test. I have given you more than one of each problem just so you have something to practice on or practice with. Okay, problem number 3 and 4 are the same thing. X squared plus y squared equal to 25 when there is a square on the x as well as the y and the coefficients are both the same and both positive, then this would be a circle. This one happens to be at the origin, and this is actually the radius squared. So the actual radius would therefore be 5. Now if you don't know these things, then you have to put it into the calculator because you don't know what the shape is. And so you can't test it for being a function. If you do want to put this in your calculator to figure out that this is the shape, solving for y, you would get the y squared by itself, pulling the x squared over to where the 25 is, making it a negative x squared plus 25. And you can switch these terms around if you like to list the positive term first. Some people do. And then you'd have to get rid of this square in order to put into the calculator by taking the square root of both sides. And on the side where the expression is that creates the circle, you're going to have to report both the positive and the negative root. Otherwise, you're only going to get one portion of the circle. think that it's a function when it actually isn't. Let me rewrite this middle part a little better. So on this side, when you are trying to get rid of a square, I'm taking a square root. Not on the side where the variable is by itself, not for the dependent variable, but over here where the expression is that causes the circular shape, that's where you want to report the plus or minus. So you're actually you'd have to enter that in as two functions. Okay, this would now just be y, but you're going to do y1 in its positive sense, 25 minus x squared, and you would enter as the second function this same expression, but the negative version. And when you put this in, then you would be able to discover that it's a circle. So you would have second square root 25 minus x squared, close that up, and then you would do a negative version of that, 25 minus x squared. Close that, graph it, and you would see the top part of the circle, and then y2 would give you the bottom part of the circle. There would be your shape. When you pass a vertical line through this graph, it makes 2 points of contact, therefore it's not a function. That vertical line cuts through the graph both times at the same x value. So this particular x value has two different y partners. One y value up here, let's call it, and then that same x, both of these points, because they're lined up vertically, have the same x value, but this one would have a different y partner. And anytime any x value has two different y partners, it is not a function. Likewise, you could go through the same thing for problem number 4, so I won't do that one. I will graph it though. I'm not going to go to the calculator, but of course I'll give you something for that one. This would be x squared plus y squared equal to 81. This is the radius squared. Again, it's a circle when these are both positive, both squared, and both of the coefficients are equal. That makes it a circle. There are certain characteristics of an equation that give it its shape. So if this is r squared, r would be 9. So if you wanted to graph this by hand, because you knew that it was a circle, it would go out to 9 in all 4 directions. And being that it is a circle, it fails the vertical line test. No matter where you drop the vertical line, just like number 3, fails the vertical line test, this one fails. When we fail the vertical line test, it's not a function. That completes numbers 1 through 4.